Alrighty, happy Monday, our first full week here. And the weeks are going to be a little bit weird for this class because we've got lecture in the morning, Monday, lab Monday afternoon, lecture Wednesday. So we'll see how that schedule goes. Had a chat with Dr. Saeed. He should be all set for labs starting 4 p.m. today. I've got a lab from 2 to 3:45 in that room, so I might just hang out till about 4 o'clock or so and say hi to him. Uh, I don't know if he and I have ever met in person. I'm trying to remember here, and I get 100 plus new people every semester, and names and faces are just a blur to me. Unfortunately, my apologies there. Um, but I might be there to say hi, and then take off. So make sure you attend lab with him. It's his lab section, so whatever he says goes. Right? I'm going to do what I do for the lecture sections. He's going to do what he does for the lab sections. It'll be a little weird, but we'll make it work. Okay. So at the end of the day here, he's going to tell me um, what percentage of this 10% of your grade you get for attending labs and participating in the labs and submitting the labs and grading the labs, right? So that's his section there. That's the time he's got to sit around, walk around, help you actually look at your code, right? It's hard for me to do that during lecture time. Right? Even if you're following along on your code, I can't stop what I'm doing and go look at your computer and see why you're getting some weird error or the red lines or whatever. So um, that's what that's for. If you got questions on the lab, they go to Dr. Saeed, right? Because he's running the labs. You've got questions about the lectures and the projects, they come to me. Again, it's a little weird, but it's okay. We'll get used to it here, and we'll figure it all out. Does that make sense? Okay, cool. So we got through most of chapter 2. There's a lot to do with variables. It's okay. A lot of information here. This by itself, though, is really boring because the only thing we ever really do is like, here's a variable, and then I did arithmetic with it, and that's it. So we need to get into branches to make it more interesting, and then we can start talking about our first project because this will be a whole lot more fun. So we're going to use variables when we start talking about branches here. Okay, just like any math class, you don't get to forget the things you've already learned. We're just going to keep building on these concepts. So if something didn't make sense in the first week, week and a half, like I don't know, these are like half weeks or I don't know, whatever you want to call these here. You got to let me know. Go to the SI sessions. Ask somebody, ideally me, because that's my job to answer your questions. Right? That's kind of why they pay me. Otherwise, you could just watch YouTube videos, right? Okay. So my job is to answer your questions. Happy to do that. So, and again, I talk fast. I got a whole pot of coffee here. I already had coffee before this pot as well. So I did not sleep much last night. So I'm rather hyper at the moment. If you're a little fuzzy on something, holler. Okay? Because if you're fuzzy on it, one of your classmates is fuzzy on it, and they'll appreciate you being the one to raise your hand and say something. Okay. I think I want to try and start the project today. We might. That's okay. So you might not be able to finish it today. That's okay. The goal is this will, not necessarily be 2 weeks worth of work, but you've got time to spread it out over the next 2 weeks here. Okay. So on intro today, so I'll try and pause about noon or so of me talking at you here, and then switch over to explaining what the goal is with the project. Okay, and we'll go through that way. I'll show you the GitHub steps. Oh goodness, sorry. Is my sugar high? Sorry. Um, why are you beeping at me? Yes, sugar is high. Okay, it's coming down. Should be okay. It might keep beeping for a while. It's not the fastest thing in the world to change. So sorry about that. All right. Um, yeah. So I'm going to start up a new project. I go to Visual Studio and do a new project. Everyone, I'm assuming, got Hello World working on your device, whether or not you have a Mac or Windows PC. There's a lot of Macs. My goodness. It's like at least a third of you, maybe close to half. Wow. Okay, that's fine. It'll totally work. You can do all the things you need to do on Mac. Um, Not a problem, but it'll just look a little different because Xcode is not Visual Studio. Okay. If you want to use Visual Studio, we've got it on the lab PC. So when you get to lab, you can use the Windows computer if you want. Right? You can log in on lab PCs and do it all in Visual Studio if you'd like. Here, either way should be fine. You'll still end up with the CPP file. That's the important piece here. I like all of the other stuff that comes along with it. It makes life easy. Git is fantastic, lets you track all that stuff. And then if something happens to your computer, you can just pick up where you left off really easily. All right. So we're officially in week 3, which is weird. It doesn't feel like week 3. So again, empty project gives us nothing. The console app gives us the starter file and an int main. So I prefer this one because it saves me some typing. I don't have to memorize any of that other stuff, right? So I like the console app. I'm going to put it in my Git repository folder. Okay, so when we get to the project, I'll show you how to make your own repository. We'll go through the steps of cloning it. Take you through all of it. Don't worry. Um, it's going to be a lot of clicks, but we're going to do it every time for every project, and eventually we'll get into the habit of it, and it'll feel pretty comfortable. I promise you it's worth it. Git is fantastic. Using source control is worth it, even if it's just you. I know you can put it in some sort of cloud drive, but this is the right way. It's good to get into the practice of using it here. And what is it? I don't know. Percentage of, oh, why did that not, oh, there we go. Developers using Git. Let's see. I'm sure we can get some stat here, right? I want 70% use Git. Okay, sure. I have no idea. Where do they pull those off of? GitHub statistics by developers? That's GitHub specifically. It's a lot, right? A lot of people use Git. It's the most widely used source control tool. Let's try that. Source control tools by usage percent. See if we can get a better result. That was weird. Enter. I broke it somehow. That's great. Okay, sure. We're getting, I just want like a chart here. No? Okay, that's fine. We can find one later here. But Git is definitely the most, oh, CVS, this one is awful. Don't use it. CVS. SVN wasn't too bad. This was the popular one before Git here. All right, anyway, we'll pick it up. We'll come back to that later. So put it in the folder. If it's in the folder that Git is watching, Git can do its job. Okay. If we don't put it in that folder, Git can't watch any of the files because nothing changed in there, right? Again, I like the GitHub desktop tool. Visual Studio has integrations right with Git. You can do that directly. Again, I use this tool because it's the exact same one for every class, and it's basic. Okay? We don't need all the extra bells and whistles that we get with all the other tools. Eventually, you'll want the bells and whistles because they let you do cool things. This one's nice and easy here. So right now, there's no changes. Right? Nothing has changed in that folder yet. Once I make my project, it's going to say, hey, there's some new stuff here. Again, we'll call it week 3. Check your box or not. It doesn't really matter here. I'll make my project. Visual Studio does its job, makes some files. So we get an SLN file, our solution file. A solution is one or more projects. The VCX proj is the project file. The CPP file is our C++ code file. And then this filters, it just let it happen. Doesn't matter here. So we get a bunch of stuff. And I can make a commit if I want. Right? Commits are free. Commit early and often. So week 3 started. Commit and push. So once I commit, until I push, the cloud doesn't have it. Right? That origin, the central repository doesn't know about it. Just my computer does. So I'm going to push to get in sync with the cloud. Okay. Until you've pushed, cloud doesn't have it, and you don't have a backup. Right. So commit and push all the time. Eventually, you can get into some other flows when you get a little bit more advanced. But for now, just commit and push. Always push. It'll make your life a whole lot easier here. Okay. And we get a bunch of garbage we're going to get rid of here. We don't need any of that other stuff here. But we get our int main. We probably should return a 0. Not that it really matters here, but it's a good habit to get into. And then again, I like using the namespace standard because that way I don't have to prefix all of my couts here with standard. Okay, just saves me some typing. And I'm all about saving typing here. And I like these end lines here. It doesn't really matter here. The backslash ends are okay too. But I've gotten into the habit of using these. And I'm a creature of habit, so I like sticking with my habits. All right, so we've got a program. It should be able to run. We should get a hello world. It's always good to give it a run. Make sure it works okay before you get started. Waste a bunch of time. And we get hello world. Life is good so far. All right. So we've worked with variables. Now we want to look at this idea of branching. Branching lets our code do different things based on different cases. So we get to come up with here. So we get a really fancy term here, a Boolean expression. Anyone know what Boolean means? What is it?
True or false?
True or false? Yeah, Boolean. It's either yes or no, true or false, on or off, right? If you do a lot of with circuits, right, we get on and off. That's a lot of fun here. And it all kind of comes back to computers. Right? It's either on or it's off. We looked at bits last week, right? That was a lot of fun. Powers of 2 with our bits. Here, it's on or it's off. So a Boolean says it's true or it's false. It's a yes or no. So we're going to use these things as true or false here. So if I have an int for, say, let's do a double here. Double for money in my pocket. How much money do I have in my pocket? Probably not very much. One, two, $12. All right, I got $12 in my pocket here. Now we can check and do something. So if we want different things to happen, we're going to say if here and then a set of parentheses. Okay, so this is where we're going to put a Boolean expression, something that needs to be true or false. And what we're going to use is our relational operators, another fun technical term there, greater than, less than, equal to. Right? How does this relate to this? So I can say, hey, if the money in my pocket is greater than 10 here, I can see out, you can get lunch at Picasso. Right? And then if it's not true here, what else do I want to have happen? We use an else. We say, if this is true, this part happens, else this part happens. And notice I use a set of curly braces. Sorry, I forgot to call that out here. Everything inside the curly braces belongs to this if. So I can have as many lines of code here as I want here. Code, whatever we want here. It will all run if this is true. Right? And then the else case here, we have to say, you get ramen noodles. Right? So if we've got more than $10, we can go to Picasso. If we don't have more than $10, we got to eat some ramen. Right? Okay. So now when I run my program, I should get only one of these blocks of code to run. I get, hey, we can get lunch at Picasso. So what happens is they become mutually exclusive. So one and only one of these will run because they're tied together here with an if and an else. So either this one runs or this one runs, which is fun. So, and then we can make it more interesting. We can ask the user, right? How much money do you have in your pocket? Oh, goodness. How much money do you have in your pocket? In line. And then instead of declaring it, and it's always 12 here, right? We can say, hey, I want a value, and then I want to want to get the input and store it in the money in my pocket variable, right? We used input last time? Yeah. Okay, good. Uh, so now we'll ask the user. And now whoever is sitting down to run my program can get a different result based on whatever they entered. Our program varies. And this is where programs are actually much more interesting because if it does the exact same thing every time, it's kind of boring. Right? So how much money do we have in our pocket? Let's try less than 10, right? Like $3, $5? We get ramen noodles. That's what we expected to have happen, right? We're testing it here because I know what it's supposed to do, but I want to make sure it does that. So I'm going to test all those different cases here. And again, we'll test more than 10 just for fun here. We'll test like 12. We launch Picasso. What happens if we enter 10? What are we going to get? Ramen noodles, because 10 is not greater than 10. Yeah, great. You guys are good at math, right? You're at least in Calc 1 by now, right? Sure. So we can do greater than. You get greater than or equal to. You get less than. Now, equals gets to be a little bit funny here because remember the equal sign is our assignment operator. So I can't say it's single equals 10. I can say does it double equal sign 10? That's our check. Does it equal the value of 10? Because otherwise C++ is like, oh, you want to assign 10 to money in my pocket? Why do you do that in if? And that was warning us with this nice little green line here. Like assignment used where equality probably intended. It's like, hey, dummy, don't do that here. That's a bad thing here, right? So sometimes the tool helps us here. Sometimes it doesn't. So again, double equals doesn't make a whole lot of sense for our example here, but that's good. Now, what if we wanted to have multiple ranges here, right? Because you can get more expensive than $10 at Picasso, right? You get you get pizza at Picasso for less than $10 if you want one of their sandwiches, one of their works of art, those which are pretty tasty. By the way, you're looking at like $12, right? By the time you get the full size one. So if we want to have more than one case here, we can do that. So all we're going to do is we're going to chain these things together. So we're going to say, hey, if my money in my pocket is greater than like $15, then you can get the whole combo, right? You can get a combo at Picasso. Now, if I just have an if and I just have an if here, they're not tied together, they're not mutually exclusive. So more than one of these can run if it's just if, because more than one can be true, right? If I have $20, this is true and this is true. If I want them to be mutually exclusive, I have to chain them together. I'm going to use an else here. I'm going to say else if. So if, else if, else if, else if, else if, else if, else if, until we get bored of it. Eventually you can have an else if you want. That's sort of your default case. It doesn't match any of these here, right? And then one of these will run guaranteed because we've got a default. If it doesn't match any of our ifs here, it'll run. Right? So we can get our combo, we can get this, or we get ramen noodles. So we can have more than one case here. So we've got like 20 bucks here. You get the combo Picasso, right? That's what we expected to have happen. So if I have less than 15 but more than 10, we get lunch Picasso, right? And then still 10 or less, right? We just said 5 bucks, we get ramen noodles. So I'm trying it. I'm going to run it often here. We've got the luxury of hitting this little run button and trying it, and it should take you 2 seconds. Right? It's not a very long lead time to test it out here, which is great. So we can try it, make sure it does what it's supposed to do. This idea we're going to develop incrementally, little bits at a time, making sure it does what it's supposed to do. You don't want to spend 5 hours writing code and never hit the run button because you're probably going to have a lot of errors that you didn't realize, right? Just shorten your cycles between writing code and testing it, writing code and testing it, writing code and testing it. It'll work better for you. Okay. So we can have as many of these as we want here, and then the else. Now we can also do dumb things, right? That's perfectly possible. C++ doesn't care if we do dumb things. So I can say else if money in my pocket is greater than 20 here, we're buying lunch for your friend as well. Right? Now, is this one ever going to run here? Can we ever get to where this is true? No. Now, C++ lets us do it here because if you have more than $20, you would have had more than 15. And this one would have run, it never would have ran any of these blocks of code here. Okay? So when we put things in a mutually exclusive chain, the order really matters. So you have to be careful to make sure, hey, the first thing, and then the next thing, and then the next thing in the right order. Right? So this can never run. First if will run instead. Right? Is that a helpful note? I can add comments every now and then here. I just forget. Right? Okay. So just be careful when you put the order in. Okay. So that's one way of doing branching here. Right? If, else if, else if, else if, else if, else if. Eventually we get down to an else here. Very exciting stuff. Okay. Um, let's look at another one. So let's do it. There's another way. So you can do something called a switch, which is similar to these here. I don't like switches. I tend not to use them just because the syntax irritates me. But you'll see it in a lot of code. I don't know why. People really like it here. So let's spit out a menu here. So enter a choice here. And we'll go down a line here. And then you want to use like 1, 2, and 3 for a menu? Right. So 1 is Coke, and 2 then is Coke Zero, and 3, um, what other beverages should we offer in our menu? Mountain Dew. Now, most places won't sell Pepsi products and Coke products here, but I guess we're special. Is that regular Mountain Dew? All right. And what else should we offer here? Do one more. Sprite. Okay. All right. Now I need to get their input. So I'm going to have an int for their choice here, and I can see in choice. Right? Again, these are probably whole numbers. Right? They're probably going to give me 1, 2, or 3 here. Life is good. Now, instead of saying if my choice is equal to 1, else if choice equals 2, else if choice equals 3, we'll do it in a switch statement. We'll do both so you can compare in a second, but we'll start with switch. So I'm going to say switch on choice. So switch on choice here, and I get a set of curly braces. So everything inside of here now is going to be what does it match? To say what does it match, I say case 1 and a colon. So if the choice is a 1, in this case, if it's a 1 here, what do I want to have happen? See out, you got a Coke with your lunch. Okay, and an end line, sure. Then I can say, okay, how about case 2? See out, you got a Coke Zero with your lunch. I don't know. This is not very exciting here. We're not giving a pricing or anything like that. Case 3, see out, got a Mountain Dew. What does that one? Do the do? That's what they say. Do the do. All right, and then a case 4, see out, Sprite for you. Now, if you want to have a default case at the end, like this kind of like ending else here, we can actually just use the word default here. So we don't say case default, it just default here, and see out, invalid choice. No pop for you. right? It's called pop here in Michigan. I don't know why a bunch of weirdos call it soda around the rest of the world, but we call it pop in Michigan, right? So cool. So I have my cases here. So let's give it a try. See if it works for us. All right, money in our pocket, $10. All right, so what do you want to drink? Coke. Uh-oh. We got everything. Switches are stupid. This is why I hate switches. So the first time it matches a case, it says, okay, sure, I'm going to keep running until I find a special keyword called break. Break says, please stop the switch. Okay? So the reason why I hate switches is because you have to include a break after every single case. And I'm kind of lazy and don't want to type break, 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 break. Here. Now, you shouldn't need a break after default here. No break needed. It's already done, right? There's nothing to break out of because the next line is the end of the switch, right? You don't have to tell it, please stop, because it's at the end. And I don't know if you notice, if you hover over this, it's telling me, hey, switch choice. This is the ending curly brace for switch choice here. It would also highlight it here, but it's kind of too far up here, too down, too far low to see that, right? And we'll see, hey, this is int main. That's the end of main here. So it's going to tell us about where our curly braces line up, which is nice. This was our else one, else. Here's the else if money in my pocket one. So you get some visual cues here in Visual Studio as well. So if we add our breaks, it should work. Let's give that a try. So we wanted to buy a Coke, $10 in our pocket. We buy a Coke. We get a Coke with our lunch. Great. Let's try it again. Again, I'm going to test each one of them, make sure it works here. It's a little bit silly, but I wrote the code. I want to make sure it does what it's supposed to do. So Coke 0, good. Oh, I got to close that one. Run it again. Mountain Dew, do the do, and then a Sprite. $4, sure, and Sprite. And the last one, something that's not a 1, 2, 3, or 4 here, like, I don't know, 10. Invalid choice, no pop for you. Okay. Now, this doesn't stop it from crashing, right? If we give it something that's not a number here, if I give it like 10, oh, it did. That's surprising. I really thought it would have crashed. I guess 10, that shouldn't have worked. That's okay. Um, we'll pretend like that didn't happen. Usually that crashes. Does it give it? Oh, if I give it a double instead of, is it just ignoring? Oh, I guess it probably just ignored it and give it 0. So 10.5. No, still didn't crash. That's interesting. That's all right. So if we wanted to do this with the if else if instead, right, we could say if my choice equals 1, cout Coke, and then else if choice equals 2, or these double equal signs, cout Coke 0, more curly braces, else if choice is equal to 3, cout do the do. I used to drink a lot of Mountain Dew when I was younger. Doesn't taste the same anymore. I don't know if they changed the recipe or I just got sick of it. And then Sprite and line, and then our last else here, right, is no pop. Invalid. Right? So sure. So here's the if, else if, else if, else if. Here's the switch. Okay. Not the end of the world here, but again, I don't like adding all the breaks. So I will probably never use a switch again. Okay. I do have to show you one more thing about switches though. There's one sort of neat thing it can do here, and that relies on this where it runs some code here. All right, so we're going to make another switch here. So we'll ask the user, what do you want to ask them? How about, do they even want to buy pop before you do any of this nonsense, right? So let's ask them. So we'll say, cout, do you want a pop? End line. And then we need a string for their input here, right? That's our, I don't know, input, sure. We can see into the input. Now I'm going to do a switch on the input. And what I want to do here is this is probably like a yes or no, right? We should tell them, hey, enter a Y or an N here, right? Oh, switch on an input. We can't switch on strings. So we can switch on chars here, a single character, which is just a single letter. Right? We looked at that last week. Right? Chars are a single letter. Sure, we can switch off of that. The problem is strings aren't number values, and it has to match on, they're essentially the numeric value. Remember, characters really just store the numeric value because it's one letter. It stores that Unicode value. So I can say, hey, case of, um, we want a Y, sorry, a single apostrophes for that. And now, what if they entered an uppercase Y because they wanted to yell at me and type in all caps? Sure. So now we say, hey, case capital Y here. So I can have two cases in a row. And remember, as soon as it matches a case, it starts running code until it finds a break. So it works to our advantage here that, oh, it matches on a lowercase y, it'll also run, it'll ignore the next case here. We can say, so all of this should happen then inside of that case here, right? So here's our choices here. I'm just going to cut and paste that in here and then add a break. So that's a big long case here, right, for y or no y, right? And really, I don't care if they entered anything other than a y, right? I don't really need a default case. I don't need anything else. I'm just saying if it was a lowercase y or an uppercase y, go ahead and run, right? And that's the end of our switch for the input here. Because it'll get to the end here and just be done. So all of this happens if you entered a lowercase y or an uppercase y, right? Now the way we could do that instead, we could say if my input is equal to a lowercase y, and now we need to add in logical operators. So we had relational operators. Is this bigger than this or smaller than this? Is it equal to this? Oh, we didn't even show not equal. We'll look at not equal in a minute here. But if you want to say, is it equal to this or equal to this? Right? We can combine those two things together. So we can say or, and in C++ land, someone decided that it's pipe, which is the shift backslash key above the enter key. I don't know why, but that's or, two pipes here. It probably relates to math, but I don't. Is that a math symbol? Anyone into math?
Absolute balance, I guess.
Okay. All right. So then input equals uppercase Y. So this is saying, does it equal this one or this one? Y or Y. So we would do it this way with an if here versus case. Right? Again, doing the exact same thing here, but we'd have this if here. Okay? All of that's still a pain here, but it's okay. It's not the end of the world. We can check here. Now the other cool thing, we can check if this was a string here, right? Now it's yelling at us saying no operator matches these operands. This is a big, long, ugly error, but we really only care about that second line. Operand types are standard string equals char. Right? So it's saying you can't compare a string to a char. Okay, that's fine. So let's go back and make this a string here. Too many. It's too helpful. It wants to add a closing quote here. Quote, closing quote. Right? So now we can compare, does the string match? So you can't switch off of strings, but you can if off of strings. Right? Does this string match another string? You'd think it'd work with a switch, but for some reason they haven't figured that out yet. I'm sure at some point it'll work, but for now we're stuck. Okay, so the benefit with these ones here then, right, can use strings in if statements. I'm going to put it back to a char. Is that okay if we put it back to a char? So we'll just go back to char here. So let me say that was a string input. If input equals like lowercase y or input equals uppercase y. Okay. If that gets too messy, let me know. I can always reorganize it here. But if we had strings, we can do strings, but we can't use a switch, right? So switches don't work with strings. Must be char only. That looks ugly, uppercase, char. Okay. Chars are integers or some numeric types here. Yeah. So when we set a string, that's a bunch of characters, one or more characters. So the way C++ stores it is different than storing a single char here. So I could enter the word yes, or I could enter yes, please. I want lots of pop, or yes, give me a Coke. Right? Whatever they entered here, we're going to store as input. We're going to check, did they give me a Y at this point here? So we can make our program do different things based on what was entered. It gets to be very exciting. Right? We finally get to make decisions here and say, you go on this branch or you go on this branch. So different things can happen based on what the user had entered. It gets to be a whole lot more exciting. And then someone might actually want to run our program because they can give it a bunch of values. We can calculate something for them, right? I think we did the monthly cost estimator, right? Last time?
Yeah.
But we didn't say if anything was true or not, right? Maybe we should tell them, hey, you know, Oh, you already spent all your money on rent. You don't get to buy food this month, right? That's a really helpful application, right? Just tell people like, just don't spend money on food, right? That way you don't stay within your budget. Yeah, okay, that was a little sad. Sorry, but we could do something like that, right? Or hey, don't buy that car, right? Don't have a $300 a month car payment, right? Just walk everywhere, right? Detroit's totally made for walking. No, okay, yeah, we don't have a lot of good options, unfortunately. But in other programs, it could be more interesting. Okay, so what if we do something like a little grade calculator? We do something like that. So we'll make it kind of basic. We'll just make it points based here. So let's come up with like 3 assignments. I'm asking for their scores on the assignments here. We should do 4 because that way we can do like 25 points each year. So we'll have an int for assignment 1 score, an int. Oops. Now, some people, I don't like it here, but you can have it on the same line here, assignment 2 score, if it's the same type here. So I can say, hey, I've got 2 different integers. I don't like this format here. Sure, it saves a line of code, and technically there's less typing. You'd think I'd like it. I just think it's ugly. That's all. But that's perfectly fine to do it that way. Or you can spread them all out here in assignment 3 score, 4 score, right? Either way is okay. I think Zybooks uses this occasionally here, so you might see it. It's not the end of the world. Oh, Zybooks. I am like a squirrel sometimes. I'm sorry. A couple of people asked about the labs. Yes, so the Zy labs, again, are part of your reading. They're tedious. My apologies here, but it's good habit, good practice to get into. Let's get very specific to the exact number of spaces that it wants in the output here, every decimal place, things like that. It's good practice here. And it will tell you if you did it right or wrong right away, right? You plug it in, you hit run or submit, and it says, yes, it worked, it worked, it worked. You didn't work on this one. Okay. It'll get more interesting as we go. So they are part of the reading. So far, 45% of people have finished the Xi Labs, 62% of people have finished the challenge, 62% of people have finished the participation. Next Monday, right? I think I set the due date for next Monday, September 15th. I'll look at Zybooks and it will give me a report by person. What percentage did you get here? What percentage did you get here? And I'll go plug that into your score here. Notice they're worth 100 points each. The points don't matter they only matter within the category, right? It just 100 points makes it easier. So I can take your percentage and just turn that into a number. 95% is 95 points. Just makes my life easier. Okay. Does that make sense? So all 3 chapters, 1, 2, and 3 are due by next Monday, right? We kind of had a slow start for chapter 1 and 2. No big deal. All right, I wanted to give you a little extra time on that here. Uh, has anyone worked on the Xylabs yet? Do they take a lot of time? A little, okay, a little bit of time at least. So don't wait until Monday. These are due at 11:59 p.m. Don't wait until Monday at 11 p.m. Be like, oh crap, I have to do my Zybooks. That won't work well for you, right? Okay. Again, this is your incentive to read the book, right? You get free points for reading the book. You can't get these wrong because you just keep trying, right? You can, I guess, get it wrong and leave it wrong, but if you get it wrong, it tells you and you get to try again. So I would like everyone to get 100% on these. That's what I would like. It's okay if it doesn't happen. It's up to you. You can prioritize your time and say it's not worth the 10%. It's up to you. It's okay. Not the end of the world here, but put the time in and you'll get the points is sort of the idea with this one, right? If you have questions about them, let me know. They're usually pretty straightforward, right? It'll get a little bit more complicated as we get into stuff like, hey, a branching lab here. Let's go look at some of them here for leap year. Sure, let's go look at leap year. A year in the modern Gregorian calendar consists of 300. Oh my goodness, I'm bored already. um, sure, February 29th. So if the year is divisible by 4 here and divisible by 400 here are leap years. So figure out if it's a leap year or not. So right, we're going to input the leap year. This sets a Boolean value. Oh, we didn't look at Booleans, did we? You can have a Boolean of true or false. Right? We could have a Boolean expression that resulted in the true or false. You can also just have a variable and set it to true or set it to false, which is a lot of fun here. So write some code, right? Hey, is it evenly divisible by something? Or we looked at an operator called modulus that would give you the integer remainder of something. So if it's evenly divisible, is there a remainder? No, there's no remainder. So the remainder should equal 0, right? Do your modulus, check the remainder. If the remainder is 0, right? So we would have to store that, right? So um, an int for remainder is 100 modulus 4, right? Oh my goodness, I can't spell remainder here, right? And then I can say if my remainder is equal to 0. No, I still can't spell remainder. My goodness, right? That sort of thing. But remember, there's another case as well, right? Not only divisible by 4, but also divisible by 400 if it's a century year. Oh my goodness, right? Well, how do we know if it's a century year? Yeah, check divide out all the hundreds. See if there's a remainder, right? So you can put ifs inside of ifs if you want, right? We put an if inside of an if. Oh, did we? We didn't yet. I thought I did. So hey, if the remainder is 0, right? Remainder is equal to 0. Oh my goodness. I should use the type ahead. Remainder equal to 0. Oh goodness. Okay. Then if I don't know, we wanted to check if the year divided by 100 or something. I don't know, whatever we wanted to check here, right? That input, whatever happened to be, right? Modulus 100. Oh, don't do that, right? Equal 0, right? To have a check inside of a check, that's okay too. You can have these as nested as far as you want. You can put an if inside of an if inside of an if inside of an if, all the way off to the right side of the page here. You've probably gone too far at that point here. You want to be able to read it and not have to scroll left and right is ideal, but it's okay. You can have an if inside of an if inside of an if. Usually 3 or 4 levels is okay, not the end of the world. Right? There's other ways we can do it, and we'll get to those as we get into more code, but that sort of thing. Does that make sense? Right with that one? Okay. So that's what we're going to do with like the Xylab. So you have to go write the code here. It goes and does it. And you say, I want to go run it here. And if we did the result right, should we try this one? Should we actually do it in the Xylab here? Okay, sure. So we got an input year. So we'll type our code here. So let's check. Hey, if input year modulus 4 equals 0, we're going to set is leap year equal to true. Must be a leap year, right? Then we output leap year, not a leap year, right? I guess we don't even need to change that. We could just say, hey, if it is, then, right, we see out the input year with a dash, right? Space and a dash, right? It's very particular about the spaces here, right? Leap year, probably an end line. If it's not, then, right, see out input year dash not a leap year, right? Let's give it a run. So we're ignoring the centuries right now. That's okay. We'll come back to it. Let's see if the basic part works for us here. And it shows us our little output here. Uh-oh. Unused variable. We never used it. Okay. Is it submit for grading? It's just a warning, right? We should be okay with that. So score 8 out of 10. Okay, so this one worked, not a leap year. This one worked, leap year. So it expected this, it got this. 1900 should not have been a leap year. It was a century, so we didn't finish all of our cases, right? So if it's divided by 4, then, right? If it's also then a century year divided by 400, so we need another case before we decide whether or not it's a leap year or not, right? So then if my input year modulus 100 equals 0, that must be a century year, right? That's the century year. Okay. If that is true, then it also has to be divisible by 400 then. So if it's a century year and, right, we can use a logical operator. We can say and. We didn't get to ands yet. We did ors. Ands is ampersand, ampersand. I don't know why, but sure. And here. Then input year, input year divided by 400 is 0, right? The remainder of that, right? If it's century year and it's divisible by 400, evenly divisible by 400, right? Then it's a leap year. Okay, so which one here? So we want, if it is divisible by 4 and that one, right? It's a little bit messy here. That's okay. So if I just put it here, though, right, it's not going to work for me because a lot of the years are not evenly divisible by 400, right? So if I just put it here and let's do stop and run again here. As if we're grading, we should pass the one test case, but not the other ones, right? We only got 5 out of 10 points. So we got our, oh, we got no outputs. Sure. Okay. Where's the, oh, we didn't even get 1900 is not a leap year. We didn't even get that far. right? So if it is, that's a leap year. If it's not, then not a leap year. Not a leap year. If it's divisible by 4, but not evenly divisible by 100 and 400. So it's getting a bit of a mess. That's okay. Let's see if it works for us. Again, this is not going to pass all of them, right? We got some problems, and that's okay, right? We want to kind of work at it little bit by little bit. So this one worked, not a leap year. This one did not correctly output here, give us not a leap year, right? Because it was divisible by 4, but it was not divisible by 100 and 400. So it went right to the not a leap year. Well, that's kind of a bummer, right? So we sort of need a different check here, right? So maybe the first thing we check here, again, you can do these lots of different ways here. The nesting actually gets to be a little bit ugly here. So I'm going to move all of that up to here and say, if it's divisible by 4 and 100 and 400, right? So there's my if it's divisible by 4 and it's a century year and it's a every 400 century year, right? Then it's a leap year. Then I can say, okay, else if it's not that, is it just divisible by 4, right? We'll have another leap year, right? Otherwise, if it's not that one, then let's see. So we want the end of, got too many curly braces in here, else. So if it's divisible by 4 and a century year and a 400, this one, it's a leap year. If it's not that, then, okay, is it just divisible by 4? It's a leap year. Isn't it not a leap year? Is this going to work any better, do you think? Let's see. We're still going to have some errors. Submit for grading. All right, 8 out of 10 again. Uh-oh. Still thinks 1900 is a leap year. It should have been not a leap year. Well, it didn't match this one, but now this one needs to say that the remainder does not equal 0, right? Because if any of these are not true, the whole thing's not true, we go to the next one here. So if it's not if it is divisible by 4, but if these don't match, well, it's still divisible by 4, right? So we need to check then. We can say if my input year modulus 100 does not equal, so it's the exclamation mark equal sign, does not equal 0 here, then it's a leap year, because we already checked the first one up above here. Right, let's give that a try. So now hopefully that will avoid the ones that are century years that are not divisible by 400. Oh, compilation failed. Oh, I forgot my ands here. And this tool is not as nice as Visual Studio. I do prefer Visual Studio. Let's see. And now we get 10 out of 10. Right? It's going to take a couple iterations. That's okay. You probably won't get it right the first time. Nothing wrong with that, right? We can try it and try it and try it and try it and try it. Eventually, you'll get your points here. We'll get 10 out of 10 and life is good. Does that make sense? And they had this leap year, right? So it'd be probably a little bit nicer, right? I've got the same code here twice. Anytime you have the same code twice, we should feel bad about ourselves. That's a good rule of thumb. So we can change that here, right? Because we can get rid of that warning. So at the end of this, we can say, hey, if is leap year. Now this one's fun because that's already a Boolean. There needs to be no expression. I don't have to say does equal true, right? That's redundant here. It's just if here, and it's either true or false. So if it's true, we'll input that. Otherwise, else we'll input not a leap year. And now I don't actually need a default case here because I'm only going to say is leap year equal true here, or leap year equal true. Is leap year equal true? So if it's this or it's this, will be true. You can stop and run. Uh-oh, lowercase t true, sorry. Lowercase t true. I wish we had Visual Studio. And submit. Should work the exact same way here. Still 10 out of 10, right? But now we're using this boolean here in our if else here, and I don't have to have multiple couts. There's always different ways of doing stuff with your code, right? Both worked. Both are perfectly fine here. In general, we want to avoid having the same code twice. And we don't have all the ways, all the tools yet, but we'll get there. Just to make a little bit of sense. Okay. Now, this is getting a little bit silly here because I'm saying if this thing is true, set it to true. So we could save some time here Gets maybe a little bit less readable here, but we can also now just say is leap year equals this, equals 0, right? Because that will then set it to true or false. Right? This result here, this is a Boolean expression, will either be true or false. We've set it now, but now I don't really have my else if here. This gets a little bit ugly. So I can say all of this here, right? Or all of this one. It's a little bit long here, so I'll bump it down a line here. And my semicolon. Now, this is probably a little harder to read, so I would argue the first version was probably better, at least for you folks here. If you do it for long enough, you can sort of puzzle this out here, but it's still a little bit ugly. But we're saying is leap year is going to be the result of this logical expression, which is this Boolean expression or this Boolean expression, right? And let's give it a try, right? I changed it around. Let's see if it actually works here. Hey, we still get 10 out of 10. Life is good so far. So again, 3 different ways of doing it here. So when you put stuff into chat tools, you usually get this sort of garbage here, which is really hard to read. And most of the time, when I look at people's code, I can tell if a freshman wrote it or if an AI tool wrote it, because you guys don't code the same way as AI tools. Is that's understood, right? It'll give you things we haven't done before. It'll give you things that most freshmen don't understand. Okay, we don't want to use code that we don't understand. Okay, if you look at this and your eyes cross, you don't understand it, don't use it. Just because I wrote it doesn't mean you should. Right? There's nothing wrong with the if way we had it before. That was okay. Right? We're just looking at there's different ways of approaching it here. We can combine our ifs and our ors and our ands and all sorts of silly nonsense here to get results. Okay, lots of different ways of going about it. But again, you'll do all the labs here. It's good practice. These are different than the labs you'll do with Dr. Saeed. Okay, these are just your textbook labs. If you've done the reading, you should be able to do these. That's sort of the goal here, right? So I'm going to give you examples. The textbook's going to give you examples. You're going to do practice for the Xi labs. You're going to do practice for the actual course labs, and then you'll do projects. So having done it and done it and done it and done it should make you good at it. So that's sort of how that works, right? Are you folks good at anything outside of school? Do you have any hobbies? Anyone like play an instrument or play sports, or how'd you get good at it? Practice, right? You got to do it, right? Forgot to ask you earlier. What are you all CS majors? Occasionally, we get some math majors in 150, which is so sad for math majors. They have to take C++. There's way better languages to take for math majors. Okay, no math majors. Okay, you guys are good then. So, as a CS major, do you want to be good at code? Yeah. Okay, good. It's a good answer, right? You want to be good at the thing you're learning how to do here, so we can do it. The vibe coding is useful in some cases here. Again, there's some lots of good discussion around the tool here. People are using it, and there was just one recent study. I'm sure they were selling something here because everybody wants to sell their opinion online and sell you their stuff. They're like 95% of AI related projects don't make it to production. Here's what the 5% do different. And you're like, well, thanks for selling me your newsletter or whatever nonsense here. But you can get decently far with our AI related tools or vibe coding here. I really thought was a joke term, but now people are using it seriously and it still hurts me all the time. It's okay. I have to show you the funny videos at some point here. But if I post another YouTube video and I post this to YouTube, it gets bad stuff happens. So I'll just share the links in Discord and you can take a look at them there. Um, but doesn't yet get all the way there. So you need someone who knows what they're doing to get it across the finish line and to modify it. So it's going to make developers faster, which is really cool. Right? We've used software in literally every industry in the world to make things more efficient and faster and better. Right? It's really cool. Software can do lots of really cool things here. Uh, but we need people who understand what they're doing. So if you only ever vibe code your way through school, because you can get through most projects, I'll be honest, right? Most of your undergrad, you can probably get through. Here, they're working on making them better and better and better. You can probably get through. But and you get a job and you don't know what you're doing, and the only thing you can ever do is ask the chat tools here, why would someone pay you money? Because they could just ask the chat tools too. That sort of thing, right? Like you need to have some skills and expertise here. And again, for things where it actually matters here, you could actually go and do some real damage, like putting bad code into production and crashing things, or doing wrong arithmetic and taking money out of people's bank accounts, or God forbid my insulin pump malfunctions and kills me. right? Bad stuff can happen with software. Okay. Um, oh, there's a really good Therac 25. I think that's what it is here. Yeah, there's a whole Wikipedia page here. Oh, multiple issues. We should improve it here. Someone else will improve it, I'm sure, right? I've yet to be a Wikipedia contributor. I really should be. The library actually has a really cool event for something related to women, women in technology, women in engineering. I forget what I think it's women in engineering. They sponsor it, where they'll go out and try and fix up articles about women in engineering and make them a higher quality thing, which is really cool because they tend to be overlooked. Right? We look back at the history of things, and it's just been overlooked. So, but Therac 25. It's a pretty standard case study. You'll probably run into it at some point here in health informatics, software engineering, and computer ethics here. Highlights the dangers of engineering overconfidence and the engineers dismissed end user reports leading to severe consequences. This is the radiation machine, early cancer treatment here. Um, an earlier version of the machine had a hardware stop, and this latest version, like, oh, we can put a software check in instead of a hardware check, so you don't have to like manually pull this lever or whatever nonsense it was here. I forget here. So this electronic beam here, whatever it is, that would go and send some radiation. Here they had switches. Yeah, this is what it is here. So sure, they were replaced by software checks instead of the actual locks in place to make sure it was correct. And when they were using it, it popped up some sort of error message that people just ignored. Right? There's a whole story here. You can go read about it here. And ended up killing people with radiation because they did their software badly. Uh, so since we've gotten a little bit better at these sorts of things and realized we should probably put a little bit more time, energy, and effort into checking our software. Um, but yeah, bad stuff. So what is it? You can keep pushing the P proceed key here. Error message H tilt. So they did it again and again and again and again. Uh-oh. Yeah, bad stuff happens. So software is important. All right, so for branching, let's see. Characters, order of operations. This one's kind of fun here. So we did branches, the order of operation, order of evaluation here. Parentheses. Oh, we didn't look at the not. Here we go. So not is fun here. If I have a Boolean for, I don't know, am hungry, and we'll say true here. You can say if am hungry, go eat. End line. Else, I don't really need to do anything otherwise, right? Just don't eat. Right? You don't have to have an else there, right? You can, but you don't have to. Here. So the other things you can do here, we can have a Boolean for not hungry here, and we'll say that's false because I'm not hungry. It's a little bit weird here, and that's okay. Sorry, so it means I am hungry here. And then we can say, hey, if not hungry equals false, we can do it this way here. Go eat. Go eat, right? Now, again, I think I mentioned you don't need to say equals true here, right? Because that's redundant. If it's already true, I don't need to say does true equal true. I can just say if it's true, right? Go do that here. But I should leave that as a note here, right? So if I am hungry equals true, redundant, redundant, redundant. And I don't remember. That's okay. So instead of saying if it equals false, you can use the not operator. We can put a not in front of this. So not true is false, and not false is true here. And we can avoid all of that here. So that's the same as not hungry equals false, right? We're just saying not. So that's the unary operator. It operates on one operand. Right? It just reverses it. So depending on how you want to do your logic, you're welcome to use the nots here. We also could look at if it does not, let's see, so am hungry, we could do another silly one. If am hungry does not equal false here. So a exclamation mark equal sign is a not equal sign here. So if you're not false, it must be true, right? Again, you can have these in a bunch of different ways here. Perfectly fine. So not equals. So that's really handy like for a number guessing game. Hey, guess a number 1 to 100. If it does not equal 42, you lose. Right? That sort of thing. We can use not equals. So parentheses, the unary, logical not, and then our arithmetic operators. And I think this makes a lot of sense. So if we're combining these things here, and we say, hey, if 10 plus 4 is greater than 15, right? the arithmetic is going to happen first. It's not going to say 4 greater than 15, 10 plus false. Right? That just doesn't work here. Right? So if you just think about it for a second, yeah, of course the arithmetic happens first. That way we can actually compare the results here. Right? So arithmetic happens first. Right? Then relational operators. Okay? Then after your relational operators, then you get the equals and not equals. Not too much of a problem here. Then your ands, then your ors. So the biggest problem we're going to run into is ands and ors here, because ands will happen first. So if we wanted to say, hey, if it's this and this and this or this here, let's see. I think I already lost the Xylab. That's okay. We just need to essentially put some parentheses around it. So we're going to say if, oops, put on this line. No, this line. There we go. If 10 plus 4 is greater than 15 and, I don't know, 5 is less than 20 or 20 is greater than 7, right? The ands are going to happen first. So 10 plus 4 is greater than 15 is false. 5 is less than 20 is true, but false and true, when you add them together, the whole thing's going to be false. Then I have a false or true here. So just working through it gets to be a little bit awkward. So my recommendation is just always use parentheses if you're mixing in ands and ors. It'll just make your life a whole lot easier here, right? It'll work, but parentheses never hurt. Because we're going to make it explicit. Yes, I want to have this one happen first here. Um, and I'm sorry, I forgot to show you the whole table here. So this is, oh, yes, doesn't really matter here. So I probably assumed this here. My apologies. So true and true. The whole thing is true, right? True and false. The whole thing is false. Yep. False and true. The whole thing is false. False and false. The whole thing is false. So the only way ands are true is if both sides are true, right? Now, if you ever forget about this, just remember McDonald's, right? When you go to McDonald's and order a burger, they say, do you want a burger and fries? You say no, because McDonald's fries are nasty. They're just gross, awful, bland fries. They're the worst fries out there. So, yes, you want the burger, but no, you don't want the fries. You say no, you don't want burger and fries, because then they'll give you nasty fries. And the only thing you do with them is throw them away. Okay? They're gross. Right? If they say, do you want a burger or fries? You look at them and you say yes. And then they look at you like, did you want the burger or did you want the fries? Be like, no, you asked me a Boolean question. Do I want this or this? Yes. And then they tell you, sir, this is a Wendy's, leave. Right? No. So just, right? True and true. Both sides have to be true. Okay. Ors, though, are the opposite. So true or true is either one of them has to be true. So true or true, whole thing's true. True or false, the whole thing is true. Right? Because if one side is true, then the whole thing is true. Right? False or true, the whole thing is true. And the only way you can get a or to be false is if both sides are false here. So false or false, the whole thing is false. Okay. So sorry I didn't go over that one first. I should have done that first with the silly McDonald's story here. Wendy's fries are pretty good. They're not too bad. Burger King fries are not great here. The curly fries, you want to get curly fries from Arby's though. If you want real fries, that's where you got to go. Or was it Checkers? I think there's a Checkers. It's really good too. They got some good fries. Okay. Five Guys burgers and fries. Yeah, they're okay. Not great. We should have a ranking of fries, right? Let's see whose fries are best here. Because it really makes the meal. Right? You can't just have just a burger. You need the fries with it. Otherwise, it's kind of disappointing. Okay. All right. So we got our branching here. Order of operations. Logical orders happen last. You can do this fun little. Here's the evaluation of it here. Sure, that's all good stuff here. Let's see what else was in here. Switches. We did switches. The Boolean data type strings. We didn't get to string X, so we can save some of this till Wednesday. That's good here. So we'll do some of these other things here. The conditional expression is basically the easiest way for me to know you didn't write your own code, because no freshmen use these because they're awful. I dislike them most of the time. I use them occasionally here, but that's fine. Okay, cool. So we'll save a couple things for later. That's good. Let's talk about the project. So first I need to go to my GitHub Classroom tool. Now, this has been a little flaky for me, which is a little bit unfortunate, but that's okay. It's not the end of the world. We'll make it work. So CIS 150, fall 2025. So what GitHub Classrooms lets me do is give you a link that generates a private repository that you have access to and I have access to, which is good. You don't want to use a public repository because if your classmate copies off of you, I think you cheated. Or I think they cheated, but really, I think you both cheated at some point. And that's a bad place to be, right? No one wants that. So private repositories mean no one else on the internet has access except for you and me, which is good. And you don't have to do any extra steps here. So I'm going to make an assignment here. It'll give us that link. This is CIS 15150, fall 2025, project 0 here. I don't use any of the due dates in the classroom tool. I just use it for the repository. So don't worry too much about it here. C++ template. There we go. Private repository. That shouldn't have changed. That's weird. Kind of branch, continue. Okay, create. I'll just double check that in a second here. So I'll show you all the steps here. I promise it's not too bad. It just takes a couple steps. Okay, so here's the URL. So we go to assignments. This is project. Oops, nope. Goodness gracious, project 0. So let's have this due in 2 weeks here. That'll be the 22nd at 11 a.m. Nope, 11 a.m. Learn how to read writing. We'll say 10 points for now. Again, the points only matter within the category. So just because it's 10 points and the iBooks are 100, don't sweat it here. Doesn't really matter. Okay. So here's the URL. So please submit the URL of your repository. Include a screenshot of it running in the README file. I'll show you how to do that, and a self-assessment using the rubric in the README. Okay, I'll show you how to mess with the README file in just a little bit here. Don't worry too much about that. Then we'll get to the project in a second. Okay, so we've got the URL. So what that's going to do, you click on it, and it takes you to this tool and says, hey, do you want to accept the assignment? You say, yes, you want the repository. This generates the repository. This should work. If you get an error, let me know. I just need your GitHub username, and I can fix it here. Not the end of the world. It's a pretty quick, it should go to here. It's been a little flaky, though, which is unfortunate. So this link here is a private repository. So notice it says private up here. So no one else on the internet has access to it except for you and me. So it will give you a URL in my organization. So it's Charneski, it's mine. And then the class, project 0, the semester, and then your GitHub username here. Because GitHub usernames have to be unique. This makes a unique repository. You'll have access, I'll have access. Oh, good, my search history is showing again. That's fun. When you search a bunch of D&D stuff, you get really weird search history results. HR depends on what you search. You got to be careful. Okay, and then because it's the C++ template, we get a git ignore file, which is good because we want to ignore all of the things that we don't need. I just want your source code. I don't want any of your executable files here. I don't want anything in bin, debug, release, any of that other stuff here, right? Do we actually look at any of that stuff? I don't think we have yet. If I go and open this up here, and I say, so I'm right-clicking on the project and saying show folder in File Explorer. There's a bunch of other stuff in here, this x64 folder and a debug folder. Here's an actual executable file. This is the program itself that was created here. So this is a runnable program here. And how much money do you have in your pocket? 20 bucks, right? What do we want to drink? Coke. Notice it quits right away though. There's nothing at the end. Remember when we hit run in debug mode and we get to the end here? 20, no, right? We get this little message. Hey, do you want it to close? Do you want it to not close? That sort of thing here. This is because we ran it in debug mode, it stays open. If you just run your executable, as soon as it's done getting user input, it finishes the program and closes. It's like, oh, I'm done with my job here. So running your executables is not very helpful most of the time. Okay. But that being said, right, it ignores this folder. We didn't add our executable file to GitHub because we don't need it there. We can go and build this. Right? We're only adding the source code. So the ignore file says, ignore that folder, please. Don't add that. Right? We never got any of that stuff. So here's more week 3 examples. I'm going to commit and push, get that out to GitHub. So we get the ignore file, great, and we get a README file. You want the README file. I'll show you how to do this in a second, okay? So I've got the repository. There's nothing in it yet, though, aside from the template stuff. So you're going to click the green code button and say open with GitHub Desktop. Again, there's like 5 different ways to do it. I like this one. Right? Whatever way you like is fine. And then your browser says, hey, do you want to open the GitHub Desktop application? Yes, please do that, because that's what I wanted to do. I just told it to. And your GitHub Desktop application then says, okay, I'm going to take this repository and put it here on your computer. The here on your computer can be anywhere you want. Does not matter to me. You just need to know where you put it, right? Because we're going to go put a project in that folder. Okay. It defaults to the documents GitHub folder. That's great. Life is easy if you keep your defaults, but put it anywhere you want. That's fine. And we say clone. So now I've got, and sorry, make sure you click the second option for my own purposes. Otherwise, you get some weird errors occasionally. There's another issue with the tool. Uh, it's still a lot less steps doing than having to do this manually, so I usually like it. All right, so now we've got all of it. Don't click this first button up here. It's okay. It might say open a Visual Studio. Just don't click it. It's not worth your time. So I can say show an Explorer if I don't remember where I put the folder here, right? And I get my path here. I can copy this path. That's what I usually do here. I just copy that. Works easy for me. So I'm going to come up here, copy my path. Back in Visual Studio, I'm going to make a new project, a console app. And in the location here, I'm just going to paste that in, or you can click the little three dots and go browse, go find that folder in your GitHub directory. Right? Any way you want here, go find that folder. Again, I like my shortcuts here. We can call it Project Zero. You can call it ABC. I don't actually care what you call it here. If you call it Project Zero, it'll be easier for you to know it's Project Zero when you go open it next time. Right? You get that list of here's all the projects you've opened recently. If you name it Project Zero, it's easy to find, so it's a good habit. Right? Give it a nice name here. We'll say create, and then if we put it in the right spot, we should see a bunch of new stuff. Right? I see the solution file, the CPP file, the VS Proj file, the filters. Great. I see some code. Life is good. I can start here. I don't know, Project Zero started. Again, commit early and often. Commits are free, or at least if you don't pay for the little bit of electricity they use. Don't feel too bad about it. Okay. And then again, I'm just going to hit run for a second just to show you what the README does here. So here's the running here. So in Windows land, if you hold Windows Shift S, it opens the screen snip tool. Windows key, Shift and S, and you can just drag over your output here, and it'll put that little snippet on your clipboard, which is nice. So now back over in the browser, I'm going to hit refresh here, and I should see a bunch of stuff, right? Because I committed and pushed. Ideally. Let's see. Come on. Did I push? Yeah, I did. All right, come on. Refresh. There it goes. I see my Project Zero folder. So I feel pretty good, right? I successfully see at least the starter code here. So to get something in the README file, the easy way to go about it, and I'm all about easy, is you click the little pencil. It says edit the file. So right from the browser, you can edit stuff. So I'm going to come up here and add a couple lines, right? You want to be on a new line here, and I can just hit paste it in. Control V paste. My goodness. Okay, I lost it. Hang on, I got to go back. Let me just run it again. Or no, yeah, I'm just going to run it again. Windows Shift S. Try it again. I think I got too excited. Back in the browser, Control V, there it goes. And it will automatically upload the image for you to some location. Great, I don't care where it puts it, it's some location on github.com, and it will add it as an image to your README file, which is really cool. And I say commit, it says, what do you want to call it? You can say updated commit, it's fine, updated README is okay, all that stuff is good. We'll commit. Anything you add to the README file is viewable when you look at the README file. So here's the screenshot, right? So I can see right from my project what's in the README file, which is really nice. So you're going to have a screenshot of it running here. Now, it's probably going to be more than one line, right? It's got a little bit more interesting stuff happening here. Not a lot of interesting stuff. It's our first project, right? Again, set your expectations low. It's okay. It's just our starter project here. But you'll put that in, and then we'll also do the same thing with the rubric. You can either take a screenshot and mark it up, or you can just tell me, hey, this item I got 2 points, this item I got 2 points, this item I got 2 points. However you want to do it, right? That'll work out okay. All right. That part makes sense? Again, if you're not sure, just watch the video again. Happy to ask, happy to help you if you run into trouble. The first time you ask me for help, don't be offended if I say, did you watch the video? Believe it or not, people ask me for help all the time and they didn't watch the video. And they're like, oh no, I didn't. It's like, go watch that, please. And then ask me for help. But after that, I'm happy to help, right? It's a bunch of steps. We'll get used to it. Now, in the GitHub client here, it doesn't fetch all the time. Fetch is like go look for changes. If I hit fetch, now I'm going to get, hey, you have to pull. Right? Git is a push and pull system. I made a change in the central repository in the cloud. My computer doesn't have it. So it says, hey, you need to pull that change down. Sure, no problem here. I'm going to pull that change down. It will change the README file for me. Right? It's pulling down that README change that I made from the browser. So you can actually edit your C++ code from the browser. 100% do not recommend it here because editing here in the browser is awful. And then typing C++ code here, like no one wants to do that. You technically could, but just please don't, right? Life will be easier if you actually use your real tools here, I promise, okay? All right, so we got that there. So now we got to do the actual project here. So we're going to write a party planning program, okay? So we need to know how many guests are coming to the party and what we're serving to know how much we need to buy and what it's going to cost. Okay, so we're going to have three different options here. So ask the user how many guests are coming to the party. To the party. Okay, and don't forget to include the user themselves. So like if I say I'm having four guests, that's really five people, right? Because I don't usually count myself. So make sure you're buying enough for five, not just for the four guests, because your host probably wants to eat too. Okay. Um, then ask them what they are serving. So what sort of options should we serve? We're gonna have three different options, right? If else, if else, whatever we want to do here. What things should we serve for our party here? Three choices. What do you serve at a party?
What kind of party is it?
It's up to you guys. What do you want to serve? Three choices.
Birthday cake.
Birthday cake. Okay, birthday cake. Can we just say cake?
Sure.
I'll show you why birthday cake will be problematic later. Cake. What's another option?
Pizza.
Pizza. Classic. And last option.
Pop.
Pop. All right, just pop. Yeah. Bring your own food party. Easy. All right. Three choices then. So how many people are coming? What we're serving. And then for cake, assume each person eats. Now, are your friends really hungry? Like,
Sure.
we'll say a fourth of a cake. Okay. So if you've got five people coming, how many cakes do you need to buy? Two. Right. We need to round up. I don't think you can go to Meyer and order a quarter of a cake. Probably won't go very well for you, right? So we're going to round up here, right? So each person eats a quarter of a cake. Each person eats a third of a pizza, right? I'll eat two and a third slices, right, of an 8 slice pizza. I'm sure. Don't you cut your slices in half again to make them go farther? No. Okay, that's fine. Um, and 32 ounces of pop. We should do liters, right? Because we buy these in 2 liters. Everybody drinks 1 liter of pop. No, probably not an entire liter. That's a lot. How about 0.75 liters pop? Okay. Uh, um, for pizza, assume each person, and for pop, assume each person drinks 0.75 liters of pop. Okay. Then we need to ask them, as the user, how much each item costs, right? How much does the cake cost? How much does the pizza cost? How much does the 2 liter of pop, right? Um, cost. That's one cake, one pizza, 2 liter of pop. Okay. So how much is a 2 liter? This sort of thing here, and we'll calculate the estimated cost of the items. Or so we'll tell them how many to buy. So tell them user how many of the item to buy and calculate the estimated cost. Okay, so you need to buy 7 2 liters of pop. It should cost you this much money, right? You need to buy 3 cakes. It will cost you this much money. So we don't know how to round up yet. Don't worry about it. We'll talk about that on Wednesday. Not too big of a deal. Okay, a little starter project. This shouldn't take too long, but it's a little bit of time here, right? If this is taking you more than like a couple hours, reach out, let me know, right? Yeah, question?
What would be exotic of my choice inside?
We'll just larges. That's fine. Yeah, yeah. Oh yeah, I'm sorry. That's right. That's what you're asking. So 8 slices. Sorry. So one pizza has 8 slices. But we're just assuming they eat a third of a pizza. We didn't even need to ask them here. I guess we didn't ask the user, but that gets even more complicated. Um, we don't need to do that much of a fancy math, right? Okay. So they'll pick what they're serving. They'll tell us how many people are, or they'll tell us how many people are coming. They'll tell us what they're serving. We'll ask how much it costs for that item, and then we'll tell them this is how many you need to buy. This is what it's going to cost you. Okay. The little starter project uses a bunch of if else ifs here. We got a bunch of code. Not too much here. Not too bad. And then you're going to turn in the URL. Right. Add the screenshots. Update the README file. I'll add a rubric for you in just a minute. That part's not exciting, but you'll see it here in the rubric section. So here's our project 0. And let's do correctly. Oh, goodness. Guests, 2 points. What they were serving, 2 points. Calculates the cake. calculates for pizza, and calculates for pop. Okay, so 2 points each for those 10 points here, and I'll use that one for grading. So that's your rubric. So 2 points each as we go. Okay, thanks everybody.